Let's look at another example of exponential functions in the real world by going through the drug filtering example in your homework. It says that we can assume our kidneys can filter out 25% of a drug from our blood every 4 hours. We're given a 1,000 milligram dose initially, and then our kidneys start filtering 25% out every 4 hours. First thing we need to do is we need to understand what this is saying well enough so that we can write a function to model the equation. Now, if you look at your homework, a little bit of information has been given to you. A table's been set up, x values have been given, there's a couple of y values there. I'd like you to turn off the video and take a few minutes, 5-10 minutes, and see if you can make sense of the information you're given before we go on. I think you'll find it very valuable, and then when we come back, our conversation will have a little bit more meaning. Now that you've worked on the drug filtering example for a minute, let's see if you came up with the same equation to model this particular exponential function that I did. Since our body can filter out 25% of the drug every 4 hours, it means that 75% of the drug still remains in our system. So if we have f of x equals the initial dose administered times the 75% that remains in our body after 4 hours, raised to, this is kind of the tricky part, x over 4. Because we have a value that's being filtered out every 4 hours. So the x value is only a fourth of what's happening, right? Because the x value or the exponent typically refers to time in years. This time we're doing time in hours, and since we're talking about every 4 hours, the x value is just 1/4 of that information. So let's go ahead and work through a couple of these. If we're looking for f of 0, or what happens when 0 time has elapsed, we have 1,000 times 0.75 raised to the 0 over 4. Well, anything to the 0 power is 1, so we just have 1,000 times 1, which is 1,000. So at 0 hours elapsed, we have 1,000 milligrams of the drug in our system. Okay, now let's find f of 4, or what happens after 4 hours have elapsed. So we have the 1,000 milligrams times the 75% remaining in the system, 4 hours out of 4. So that's 1,000 times 0.75, 4/4 is 1. 1,000 times 0.75 is 750. So at 4 hours, we have 750 milligrams of the drug remaining in our system. Let's take a look at 8 hours. So we have 1,000 times 0.75 raised to the second power. I hate it when it does that to me. I'm going to have to move this up first, and then this one. Okay. So we have 0.75 raised to the second power, which is 0.5625. times 1,000, which you'll see just moves the decimal 3 places to the right. So that gives us 562.5. So at 8 hours, we have approximately 563 milligrams of the medication still in our system. So if we were to graph this information, let's see what we would be working with. Generate a table here. So when x is 0, f of x is 1,000. When x is 4, f of x is 750. When x is 8, f of x is, what did we decide? 563. At 12 hours, we would have 422 milligrams, and so forth. So let's go ahead and graph this. So remember the x-axis is going to be time in hours, and the y-axis is going to be milligrams remaining in the system. So our x-axis we can label as 0, 4, 8, 12. Our y-axis, we need to go from 1,000 down to about 400. So I'm going to just go by hundreds. We'll start at 300, 400, 500, 600, 700, 800, 900, 1,000. All right. So let's go ahead and plot a few points. When x is 0, y is 1,000. When x is 4, y is 750. When x is 8, y is 563. When x is 12, y is 422. You can kind of see this is a curve. It's an exponential curve. So the rate changes because we're multiplying by 0.75. We're not adding or subtracting. Since it's a multiplication process, it's an exponential curve. Now, I know that's just a very, very beginning, but you'll be able to go through and answer the rest of the questions with this head start.